Hi everyone. So in this video we'll define some more language primitives. Before jumping into the control flow statements, we need to understand what are statements, and there are actually several more notions that are common across many programming languages, so we'll need to understand what those means before we can use them. What those mean. So several things that we will cover in this video are the expressions, statements, the comments. I think we touched upon this when discussing the sample problems, but we never formally introduced them. So comments is another thing that we need to know about, and the next thing I wanted to talk about is the statements, expressions, comments, and blocks. Yeah, so grouping statements together with blocks. So let's start with, so all of these things, first of all, are part of the language syntax, so programming language syntax, which means that every language will have its own way of writing that in the source code, and some of the languages won't have it, and so some things. So one thing I want to mention is the majority of the things that we cover in the videos so far are peculiar or more common to the imperative programming languages, but I'll try to give, I don't have too much experience in other languages like functional languages, but I'll try to give some examples where there is a clear distinction of or clear like juxtaposition of these notions, that in one type of language it's a completely different thing or written in a totally different way. So I'll try to cover those cases, but overall we'll focus mostly on the imperative languages. So when we say these things, expressions and statements, those are the part of the language syntax. We need to understand what syntax means. So syntax is basically, formally, it's the set of rules for each programming language. There is a set of rules that defines what is considered a valid expression or a phrase or a statement in this language. So what kind of symbols or keywords you can write together with what operations or operators, and to make a valid statement or piece of code that the programming language that is valid in terms of this programming language specification, and that the compilers or interpreters will understand and know what to do with it. So that's the formal definitions. But when we say this is part of the, something is part of the syntax, we just mean that this is from this language's vocabulary, right? So for instance, the definition of type or creation of a variable of type something, right? We do int a equals 5, and we say this is a valid syntax for defining an integer variable and assigning value 5 to it. Okay, so let's start with the comments first. So comments are basically part of the source code that the compiler or the interpreter ignores, which means every single thing other than comments will be considered some part of the program. So comments are not part of the program, they are just there for documentation purpose. So if you write a code and it's not very clear why you write it, or it does something complex that's not easy to understand just by reading the code, you'll add a comment saying this is done for this, or in general you'll document every function you write, or if you're writing some program that is meant for a public use, you'll document how to use it and things like that. So comments are coming handy in that, in all these cases, and different programming languages have different notations for denoting comments in the source code. Most of this, the mainstream imperative languages use the double slash for one-line comments, and slash asterisk for opening a multi-line comment, and then asterisk slash for closing it. But again, all, like many languages, scripting languages use semicolon, dash, sorry, not a dash, the hash or the sharp symbol. Yeah, there are different variations, but know that almost every language will have comments for writing something that should not be part of the code. So those are the comments. So next thing we wanted to cover is the expression. So expression, we have used expressions almost in all videos, starting from maybe like the third. And expressions are basically the combinations of operations, variables, and values, or literals. I'll get back to literals soon, and which are valid in terms of programming language syntax. And also another requirement for expression is they should evaluate to a single value. So examples that we used is when we say a, assign 5 to a, right? A equals 5. It means it's an expression, right? It's an expression and the value of it is 5. Or if we say 1 plus 2, it's an expression of type integer and the value is 3, right? It has single value. The value can be any type. It doesn't have to be built-in or primitive type. It can be user-defined, but since we didn't cover user-defined types yet, we'll get more examples later. So it can be Boolean. Let's say, for instance, you have a variable a, and you say a equals, so with double equation, 3. So it means it's an expression with value Boolean. The value will be, sorry, with type Boolean, and the value will be true if the value of a is 3. If not, the value will be false. So we can compare even two Booleans. We can say 3 equals a equals false, right? And then, which means if evaluate the value of the first, this is like complex expression composed of two expressions. And if the value of first one is true, and then we compare it to false, then the result is false. Like no one really writes this because there is a simpler way of writing this. So if a Boolean expression you want to check if it's false, you just check the opposite expression, so negate it for true. So we can say just not 3 equals a, or even simpler, 3 not equals a. So this is an example of a Boolean expression. So expressions have, it's not just the operators, there are other ways to write expressions, but for now just know that expression is something that is a valid thing composed of operations and values and variables, and some more things we'll learn about later. And the requirement is expression should evaluate to a single value. Okay, so the next thing, the literals. I missed the literals. So literal is when we want to declare a variable and assign a value. The value we write in the source code is a literal. So we say a equals 5. 5 is a literal of integer type. Or if we say some string, name equals Arsen. Arsen, and in double quotation marks, is a literal of type string. So literal is basically the source code for a fixed value of a given type. So that's what a literal is. So for instance, a double literal would be something we can say double pi equals 3.14, or many more after digits after decimal point. So that will be another example of a literal. So the next thing I wanted to talk about is the statement. So statement is basically a higher level notion than expression. So expression is a valid combination of symbols that results in a value, and statement is actually something that results in an execution. So each statement is a complete execution unit. So one statement can be executed, basically. That's the minimal thing, that if you don't complete a statement, the program cannot run. No matter if you have an expression or something which is valid, it's still not executable. So statement means it's a complete unit of execution, and there are different types of statements, or there are different ways to build statements. So in most imperative languages, you can basically use a semicolon or some other terminating character to denote that this expression or this line is a statement. So if we write a equals 5, it's an expression. But if we do a equals 5 and then semicolon in whatever languages, let's say Java or C# or C++, it becomes a statement. It means assign 5 to a, and this statement can be executed. Another example is the increment operator, right? If we write a++, it will basically evaluate to the value of a before incrementing, because this is a postfix ++. So, but if we write a++ and then semicolon, then this becomes a statement. So that can be executed. So other ways to write statements is call functions, right? We don't know about functions yet, but function calls, or some languages call it functions, some languages call it methods, procedures, subroutines, and other terms. But basically it's a piece of code that you declare as a standalone thing that you can execute, call, and then every time you call it, you can make it a statement. So another example, a simple example of a statement, is a declaration of a variable. So when we say we want, somewhere in the program we'll use a variable, so we want to declare it in advance, we can say int a and then semicolon, and that is a statement of declaration. You can also create objects. We don't know about objects yet. So object is basically a data type, or it's even an abstract data type, but we didn't get to that yet. But basically creating custom objects of custom defined types, or instances of custom user defined types, can be also a statement. So when I say if we add a semicolon, again, it's not necessarily ending with a semicolon. Some languages will have it, some languages will not have anything at the end of the line, but still result in statements. So this depends on the syntax. Again, syntax is the rules of a given language that define what is valid, what is not, what symbols or keywords can go together and what not. So those are the statements, and the last piece I wanted to talk about in this video is blocks. So blocks is a special syntax for grouping several statements together. So let's say you are writing a code for something. Let me remember one of our examples. Okay, forget about examples. Let's consider a new one. So if we want to make something, bake a cake, right? So we want to group these statements, like add flour, add water, add salt, I don't know, baking powder, sugar, and then mix, and then do something else. So if we want to do all these things as part of some group, like as a group always, we would want to group these statements in a single block. So the way we group several statements in a block is, again, depending on a programming language, the syntax might be different, but generally there are two symbols. First, we open the opening block, the symbol for opening a block or starting the block, and the symbol for ending it or closing it. Some programming languages like Java, C# C++ use curly braces. So you open a brace, the opening brace denotes the beginning of the block, the closing one denotes the end. Some other languages have different keywords for the, so when you write a statement, the statement will actually have two keywords. One just starts it and the other ends it. So for instance, in Basic or Visual Basic, I think every keyword, like if you wanted to write a condition check, if something, instead of doing if and then opening curly brace, writing your statements, closing the curly brace, you would write if something and then the statements and then end if. So it's basically the same keyword name with the prefix end. And if you have another statement like for, it would be end for. So again, and some other, I'm sure there are languages with some other specific syntax for grouping statements into blocks, but know that there is a way to do that in most languages, and that gives you a way to just group statements together, because this is useful because some of the statements, as you will see we'll see together basically in the next video even. So when we get to control flow statements, we'll see that the syntax requires that after one statement there is only a single statement or a block. So if you want to do multiple things, you have to wrap these multiple statements in a block. Otherwise, only the first one will get executed, and the rest will not be considered part of the full, the previous statement. Let's see. We have statements. We know something. So statements again. If we compare to the natural languages, statements are similar to sentences. So each one, and the semicolon is similar to a period. So each statement makes sense and it denotes a complete meaning. And the expressions would be maybe words or phrases. And then we have comments, which don't really have equivalence. Let's see. We have comments, literals. Again, those are the source code for fixed values of given types. And then we talked about blocks. So knowing this, let's in the next video, let's just jump into the control flow statements and see what those are and how they are used. Thank you for watching. See you in the next one.